Question 10. We have two radio-controlled model planes. We have A, which starts at position vector -3i minus 7j and has a velocity 5i minus j plus 2k. Therefore, the position of this one at any time would be -3, -7, 0 plus t times the velocity vector, so that's 5, -1, 2. Doing the same for B, it starts at 7, -1, -8 and has a velocity vector of 3, -4, 6. In part A, we want the distance between these two planes after 1 second of flight. So if t is equal to 1, RA is going to be -3 add 5, so that's 2. -7 take 1, so that's -8. And 0 add 2 is 2. The position of B is going to be 7 add 3 is 10. -1 take 4 is -5. And -8 add 6, which is -2. So the distance will be the square root of 10 minus 2, all squared, that's from the i's, plus -8 add 5 squared from the j's, add 2 plus 2 squared from the k's, that's the square root of 89, which is 9.43 meters, correct to 2 decimal places. In part B, we're asked to find the shortest distance between the two model planes and the time at which this occurs. You can always solve this type of problem with relative motion by doing the following. Take this point as A relative to B and this direction as the relative velocities. When this is a right angle, we have the shortest distance and the time at which it happens. Now, A relative to B is the position vector for A, so that's -3 plus 5t, -7 take t, and 2t, so that's just putting this together, take away the position vector for B, which is 7 plus 3t, -1 take 4t, and then -8 add 6t. Calculating, that gives me -10 plus 2t, -6 add 3t, and 8 take 4t. If we do the relative velocity, so that's AVB, that's going to be the velocity of A, 5, -1, 2, take away 3, negative 4, 6, which is the velocity of b, and that gives us 2, 3, negative 4. So we need to solve negative 10 add 2t, negative 6 add 3t, 8 minus 4t, dot 2, 3, negative 4 is equal to 0.
So we're solving a dot product. So action advanced solve. Then inside here we're going to need our vectors. Go to 2D, calc, and we have the vector templates. We want a column vector with 3 rows. We want the dot product. If you go to category, it's probably best to go to E and then go back up to find dot product. The function we're after is dot p. So it's this one here. So we need to insert that. Then we want a comma. And we need another column vector. Close bracket. We want that equal to 0 because we're solving when they're perpendicular. So we just need to fill in our vectors. So we have negative 10 plus 2t, or I'm going to call that x because it's easier on the calculator. Then we have negative 6 add 3x, and then 8 take away 4x. Then we've got 2, 3, negative 4. And execute, and we get 2.414 if we round to 3 decimal places.
So we now have that t is 2.414 seconds. Then, if we substitute that back into the relative position vector, we'll find that their relative position is negative 5.172, 1.242, and negative 1.656. So the distance between them, we just want the magnitude of this vector, so that's the square root of this one squared, plus this one squared, plus this one squared, and that gives us 5.57 meters, correct to 2 decimal places.